So most of the time, so far at least, in this section of the chapter where we're talking about equilibrium and Q values, the temperatures are just like saying, hey, it's the ratio at this temperature, and you're not actually doing a calculation with the temperature. This is one of the few times that you are dealing with temperature because this is converting between pressures and concentration. So the temperature is mattering because the pressure is needing that temperature value to get the answer right. I've seen this both ways. Sometimes teachers will just give this equation, sometimes this equation. They are the same equation. Just so you know, if you divide both sides of this by RT delta N and then RT delta to the delta N, you can actually write an RT to the delta N in the denominator. If you want to put it up in the numerator, you just give it a negative. So if you want to just learn one of the equations, totally fine, totally fine. I'm just saying, make sure you're paying attention to your signs because you can see it does matter, that sign in there for which one you're solving for. So for this reaction, we have this Kc, and also I want to mention that you need the R and the R for these. That's the gas constant because you're doing the conversions, again, you're into gases, you're dealing with gases. So we're solving for Kp, so that's that top equation. So 4.5 times 10 to the 4th times, and then I need to make sure this whole thing is what gets in for my delta N. And I'm going to put all this all in my calculator at once. So 0.008, I don't know, both times I wrote 0.0821. I didn't mean to. It's just 0.0821. So 0.0821 times, and then my temperature is at 400 plus 273.15, and the whole thing is raised to the change of N. So let's double check for our change of N. So here's my products, and then my total moles of reactants is 4. So 2 minus 4 is negative 2. So my delta N over here is actually negative 2. So I'm going to go ahead and write the other one out so then I can put them both in my calculator at the same time. So the other one I have Kc, so I'm using the lower equation, equals 29.5 is the value of it times 0.0821. Yeah, that's my problem with that. And then this one is 800 plus 273.15. And then that's raised to the, okay, so I have 2, because that's a 1 and a 1. And then there's a 1 on that side. So my delta N here is 2 minus 1. Now, be careful, though, because I'm using this lower reaction to solve for Kc. I'm having a negative in there because the reaction itself, like the equation, has a negative in this situation, but my delta N is the positive 1. So you can see scenarios where like you'd have a negative, which would make it a positive, all that stuff. So that should be set up correctly. I'm just going to put them in my calculator, and so I will get 4.5 e to the 4th times, in this whole thing, 0.0821 times parentheses 400 plus 273.15, parentheses close. So see how I've got this all in the same, raised to the negative 2. And you've got to use the plus minus key thing, not a minus sign. So that gives me 14.7. Or if I'm rounding it to the 2 sig figs right there, that gives me 15. Now the next one is 29.5 times parentheses 0.0821 times parentheses 800 plus 273.15, parentheses close, parentheses raised to the negative 1. And that gives me 0.335.